we've done a lot in our spatial modeling. So specifically spatial referring to just better 3D model results. So for example, if you're building a multi-barreled culvert, previously you had to place each conduit, one for each barrel, and we know that wasn't, looking back on it, not a great solution. We know that that kind of caused issues with diverging links. So we wanted to simplify that and use the hydraulics engine the way it wants to be used. So with this newer enhancement, we simply just state the number of barrels and the gap between them, and the 3D model will correctly reflect that in the 2D and 3D view. And it also works with the hydraulics model as well, because it now has an understanding that that should operate as one single pipe rather than 4 separate pipes. We also enhanced placing inlets by spread. Now you can place them in batch, but it will kind of automatically calculate the positions needed for an inlet or a series of inlets to help drain an entire road surface according to spread constraints. And we'll also create your drainage area polygons that will show the, for that inlet, for each inlet, I should say. So you can now batch set series of inlets at kind of more of a, based off of a spread limit instead of equal intervals. All right. So let's go ahead and take a look at some of these videos here. So here we have 4 separate conduits. This is kind of how it used to work. We're going to go ahead and delete these. Yeah, and you have to have a connection region on each cell as well. It's kind of difficult to make. Okay, so here we're going to go do 1 4-barrel culvert. Notice that there is no gap width. We can always go into the properties, set multi-barrel gap. So we have 0.2 meters in this example. In this one, we've got 2 kind of flanking pipes. So, right, and then we have a, here, as soon as it gets selected, there we go. So you can select the diameter, and then for these outer 2, we're going to say is diversion link is true, and then from there we can kind of customize those outer pipes as kind of, like a bypass or a supporting pipe. We know that when you kind of place the conduits between the nodes, that if a node changes, right, it's no longer really radial to the center of these circular inlets, right? And then you'd have to go manually move these connection points around. It can be kind of tedious. But recently we've implemented a connection point that can be customized in the cell. And now if we go move our pipe connections instead of to the surface edge to the actual center points or these connection points, it will still trim to the connection regions that's kind of on the perimeter, but it will kind of project it will try and at least stay collinear with these connection points to kind of help when these nodes move around, and it also helps when rotating the nodes. So it's really trying to project to the center and then kind of being clipped or chopped to the node edge. So it helps with rotation a lot. Okay, so here we're going to look at how to batch place inlets, but instead of by equal spacing, we're going to go look at spread. So in this example, we have 4 feet of spread and 6-inch depth. We're going to go ahead and place this type C inlet. Okay, so we have our capacity calcs there. or I guess the physical data that will be used for capacity analysis, we're going to go ahead and use the place nodes command and then select spread instead of interval. Now, we have to select a gutter flow line, or at least some line that will represent where to kind of, it's an offset alignment basically, right? Where do we allow the nodes to be placed? Go ahead and set a start and stop station. We got, for this example, we have an existing inlet we want to tie into eventually. It's going to take a minute here because it will do all of the capacity analysis for these inlets, for the spread calcs. And you can kind of see there how the frequency increases of these inlets as the slope decreases. And we also have the catchment areas drawn. So we have each drainage area. Let me see here. We're going to go ahead and compute. And if we go ahead and look at the details, you can see here that we can look at our gutter depth and our spread width. You can see that it's preventing the spread widths from going above 4 feet there. So it kind of figures out where the first fail point is and kind of backs it up. So we hope that will help. And in this example, we're just looking at a proposed terrain. The terrain it can analyze can be any size. It's just this example, we're only analyzing the proposed roadway, but if you have off-site drainage, it can factor that in as well. It's however big your terrain is. So I think that's pretty awesome. I think that will save a lot of time. And there are some options where if you wanted to link them with pipes or not. In this example, we showed we did not link them with pipes, but that should be a feature available if we want to set a conduit to auto connect. But that can take longer to process because it's more steps. It will not size your pipes for you. At that stage, you would then execute run your hydraulics, and then it would calculate your pipe diameters. So down in Project Explorer, we've improved the nodes. That's going to be now alphabetically. We've renamed this where it says links used to say conduits, and people were kind of getting confused there. And we looked at this and say, yeah, we can do a better job with labeling that so it has gutters as well. And the profile runs are also listed alphabetically. If we select several profile runs here, we can right-click to get the refreak cuts on these selected profile runs. So we know that it was kind of a pain to go through and do each one manually, so now we have a batched one, and we also have the referenced models down here as well. Kind of get the same kind of hierarchy, but this is just for referenced in data. So we kind of separate it out so it's easy to see what file is it coming from, how many drainage files are referenced in, if you have 10 different reference files with drainage, and I'm trying to look through some drainage items, it's a little bit easier to say, okay, got reference models, and then go find what you need in those. The next video here is going to be about kind of watersheds, which we've heard a lot of feedback about. So most of y'all are probably aware that you could have done these drainage flow arrows, but you kind of have to then use your imagination to kind of figure out, okay, well, what's the limits? Or you'd have to use the analyze pond, analyze trace slope, and that's a little bit more manual. See here in the video, we selected analyze catchment. This is now you open the compute catchment of wherever the cursor point is. So it will find the low point and then kind of select everything in that region. So it goes from this point downstream and finds the whole upstream that flows to that downstream. So we do have two elements here. One's a shape element, and one is going to be the kind of the polygon. So we kind of have, we have the shape and a point. So we have the low point and the perimeter as well. We can use a fence if we set up a fence, if you just want to analyze a specific area on a large terrain, or we can do everything. So we think this will help a lot. We know that there's